The last section in leaving cert probability deals with something that crosses over into statistics, which is the normal distribution table. So if we look at this table of numbers, we have a Z. So from this table, we get what's called a Z score. And this table is based on Z being the standard normal variable with a mean of 0 and a standard deviation of 1. So we look at what standard deviation means now. So let's just do a normal distribution curve that I'm sure all of you have seen somewhere along your travels. And this one on the right here has an average of 0 and a standard deviation of 1. So that means there's a +1 here. We're up to 2 here. We're up to 3 here. And all in here, these are what are called my outliers. +3, more than +3 standard deviations. And to the left hand side of the center, we have a mirror image. There's 50% on both sides. This is -1 standard deviation, -2, -3, and again I have my outliers in here. My outliers. Now, where are those trees? You can see down the bottom here. My table goes from 0 in the middle, representing 50%. You can see here. If we get a Z score of 1, what does this represent? 84.13%. We look at a Z score of 1 now in a minute. A Z score of 2 would represent 97.72%. And a Z score of 3 would represent 99.87%. This leads us into what we have in leaving cert statistics, the empirical rule, which rounds some of these figures off. This is the 68, 95, 99.7 rule. And this is +1, +2, +3, and includes the minus. So if we take 68%, it's between the first and second standard deviations either side of the 0, and that represents 68% of the data. And how does that work for this one? How can we get 68% if it's telling me 84%? So let's have a look how that works. So a Z score of 1 gives a number of 0.84. Now it's 8413. So if we draw a curve, and here's our center at 0, we take +1 to be here, it's telling me that this is 84% of all the data is to the left of this +1, which means how much is in here? 84 and 16, so 16% of the data is in there, which would mean that if I draw a line, because this is a symmetrical curve, it would also mean that 16% of the data will be from -1 back if it's the same as from +1 up. So if you add 16 and 16 together, you get 32, and 100 minus 32 is the 68. That's part of the empirical rule. This 68% ±1 standard deviation. You get the same maths involved when you do 95%. So the tail at the end here is 2.5% to give us the two tails being 5%, and we look at that now at number 2. We can see here 0.9772, so about 2.3%, and when we multiply it, we will get exactly 2. Well, we won't get exactly 2, it'll be closer to. So where will we get exactly 2? And you can see if we look at this number 975, that's 2.5% below 100, so the two tails would be 5%. So actually this is the exact number. You can see the rounding involved here. This is 1.96 for exactly 2 standard deviations. This one here is 1.96. If you see the 1.9, and if we go to the top of this row, or the top of this column, we get our 6. So 1.96 we're going to see when we go to statistics. So that's kind of introduction into this curve. What types of questions can they ask in relation to this within the probability section? Let's have a look at a couple of them. So we take these two questions as an example in this video. The probability that Z is less than 1.22. So always draw a sketch. Here's your 0. It doesn't really matter where we put the 1.22, just give yourself enough room to write 1.22 in. So that's what the Z score is, 1.22. So what does that represent? Let's have a look. We're looking for the blue bit to the left, 1.22, 1.2, and this first column here is a 0, so 1.22 is the third column. So 0.8888, 0.8888, which means that 88.88% of the data is in this blue bit, and in the red bit to the end we have 1 minus 0.8888, but if it's 88.88, you can see that leaves 11, 99.88, 11.12% will be this red bit in here. So the probability of less than 1.22 is a 0.8888, greater than 1.22 will be this 11.12%, and so on. So greater than or equal to 2.37. Just do your basic sketch. Let's put it here, even though it'll be much further to the right, just to give ourselves some room. So this is 2.37. Remember, with the sketches, we don't have to be accurate. We're just looking to help ourselves by identifying something on a diagram. So let's go up to 2.37 here. 2.3, 0, 1, 2, 3, 4, 5, 6, 7, or just go 9, 8, 7. So we get 9911. 9911. So the Z score of 2.37 gives 0.9911. And because we're looking at greater than 2.37, we're just looking for the bit in the tail. So 1 minus 0.9911, and we'd have to add 89 onto that to get it all the way up to 1. So that's equal to 0.0089.